You know, we all use services like Dropbox, right? We drop a file on your laptop and boom, it just shows up on your phone. It feels like total magic. But behind that simple little action is this whole world of brilliant engineering. So today, we're going to pull back the curtain and see exactly how that magic really happens. I mean, think about it. You're working on a presentation, you hit save, and you head out the door. You can just pull it up on your tablet at a coffee shop without even thinking about it. This seamless sync across all our devices, it's something we totally take for granted, and why shouldn't we? It's supposed to just work. But how? How does that file actually travel from one machine, shoot across the internet, and land perfectly on another, sometimes in the blink of an eye? That's the real mystery we're going to solve today. At its core, any cloud storage service is really making three big promises to you. First, there's availability. You got to be able to get your files anywhere. Then, reliability. You can't ever lose your data, right? And finally, scalability, which basically gives you what feels like infinite space. And look, these aren't just fancy words on a website. They are the absolute core goals that drive every single decision the engineers make. Okay, so to see how they pull this off, we really need a map of the whole system. Think of it like a play with three main characters, and each one has a super specific and really crucial job. So let's meet them. Okay, first up, we've got the client. This is that little app that's running on your computer, your phone, your tablet, you name it. You can think of it as your personal assistant right there on your device. It's the one watching for changes and kicking off the file's entire journey to the cloud. All right, next, meet the metadata server. This thing is basically the brain of the whole operation. The best analogy is a master librarian. Now, the librarian doesn't hold the books themselves, the actual files, but it knows everything about them: the name, the size, who made it, and crucially, a master list of where every single piece is stored. And last but not least, the block server. This is the real muscle, the workhorse. I like to call it the infinite warehouse. These are the servers that do all the heavy lifting, actually receiving, storing, and sending the raw data of your files. They handle all the physical storage. Okay, so here's how this whole team works together. Your client on your machine is constantly talking to two different players. It tells the metadata server about any changes, and it sends the actual file data over to the block server. So the metadata server keeps its own little database, that master library catalog we talked about, while all the real guts of the file, the data itself, lives in this massive cloud storage system that's managed by those block servers. All right, we've met the cast. So now let's follow a single file on its journey. What really happens step by step the second you hit save on a document? The very first thing that happens on your computer is a process called chunking. It's super smart. It breaks your file, no matter how big it is, into these small, manageable 4-megabyte pieces called chunks. Now, why do this? Well, think about it. If you have a huge 100-page document and you only change one sentence, Dropbox only has to sync that one tiny modified chunk, not the whole thing. It's incredibly efficient. And what's really cool is that the client software on your device is like its own little mini company with different departments. So first, you've got the watcher. Its only job is to notice that you saved a file. The moment it sees a change, it pings the chunker. The chunker does exactly what it sounds like. It splits the file into those pieces. Then the indexer comes in and updates a local database right there on your machine to keep track of these new chunks before a single byte even gets sent to the cloud. So the whole sync workflow basically breaks down into 4 steps. First, your laptop, let's call it Client A, uploads only the new or modified chunks to the block servers. Step 2, it pings the metadata server and says, hey, I've got a new version of this file, here's the new recipe for it. Third, the system immediately sends out a notification to your other devices, like your phone and your tablet, Client B and C. And finally, those devices get the message and know to ask for and download just those specific new chunks. Done. Synced. But wait a second, how do your other devices get that notification so blazing fast? Well, they use this really clever trick called long polling. Instead of your phone constantly bugging the server every second, anything new, how about now, which would just be a huge waste of energy and data, the client just opens a line to the server and waits. The server holds that connection open and only sends a reply the instant there's an update. It's exactly like waiting for a friend to text you. You don't keep calling them, you just wait for your phone to buzz. Okay, so that's the basic process for one file. But how in the world does the system handle not just you, but 500 million other users, all at the same time, without just completely falling over? This is where the real genius of scaling comes in. I mean, let's just try to wrap our heads around the scale here. We're talking about 500 million users. That's a system responsible for storing over 10 petabytes of data. A petabyte is 1,000 terabytes. It's 10 million gigabytes. To manage that much stuff, you have to be almost absurdly efficient.
Okay, so one of the biggest, most powerful tricks in the book is something called data deduplication. When you upload a chunk, the system gives it a unique fingerprint called a hash. And if it ever sees another chunk from anyone, anywhere, with the exact same fingerprint, it just doesn't store it again. Nope. It just creates a little pointer to the copy that's already there. Just think about what that means. A super popular song or a PDF user manual. That file might only be physically stored once on Dropbox's servers, even if 1 million of us have it in our accounts. This one idea saves a staggering amount of space and money.
Now, like with most things in engineering, there's a trade-off in how you do this. You can do inline, which is kind of like a super neat chef who cleans as they go. It's really efficient for the system, but your upload might feel a little slower because it's checking for duplicates first. Or you can do it post-process. This is like the chef who just wants to get the food out the door fast, makes a huge mess, and then cleans it all up later. The user gets a faster upload, but the system temporarily uses more space and bandwidth in the background.
Another huge piece of the puzzle for keeping things speedy is caching. Systems like this often follow the 80-20 rule, which basically says that 80% of the traffic, the requests for files, is usually for the same 20% of the files. So the system is smart. It identifies these super popular, or hot, files and keeps a copy of them in a really fast, easy-to-access memory cache. It's just like how a coffee shop keeps the most popular stuff right on the counter so they don't have to run to the back room for every single order.
And finally, how do you handle millions of requests every single minute? You need load balancers. Just think of them as traffic cops for all this data. They stand between all of us and all the servers, and they intelligently direct our requests to a server that isn't busy. This makes sure no single part of the system gets totally slammed and everything stays fast and responsive for everyone. So let's take a step back. We've talked about chunking and long polling, deduplication, caching, all these incredibly intricate parts working together in concert. So what's the real takeaway here? What's the point of all this complexity? Well, it all comes back to that one simple promise. All of that mind-bendingly complex engineering is designed to be completely invisible. And that's the whole point. It all exists for one reason, to make good on that motto. Your data available anywhere, anytime, so that it just works. So the next time you just drag a file into a folder and watch it magically appear on your phone, maybe take half a second to appreciate that incredible invisible dance of data that's happening behind the scenes. And it makes you wonder, right? What other simple apps that you use every day are being powered by an equally brilliant and totally invisible architecture? Something to think about. Thanks for diving in with us.